Simplifying rational expressions. A rational expression is a fraction where both the numerator and denominator are polynomial expressions. When you have rational expressions, you always need to remember that there are restrictions if there are any x's or variables in the denominator, which is the bottom. Okay, if you have any variables on the bottom, you're going to have restrictions. For more about these restrictions, watch my video, Rational Expressions Restrictions. Special note, if you are given a rational expression, you always find the restrictions before you simplify. But for the purposes of this video, I am not going to find the restrictions for time's sake. I don't want the video to be so long. It's going to be long enough as it is. So understand that they exist. In fact, just about every problem we do, if not every one, has a restriction in it. If it has an x or a variable in the bottom, the denominator, it has a restriction. All right, so I'm not going to find them, but I have a video for that. You can look at it, but you would find it before you simplify, okay, before you do what we're going to do here. When you simplify rational expressions, even as we move on to basic operations like add, subtract, multiply, and divide, the last two steps will be to factor and divide out common factors. All right, I prefer to leave both the numerator and denominator factored, as this says to anyone, I know nothing else divides out. Now, if your teacher wants you to distribute that 2 back through there, if we get 2 times x plus something, you do what your teacher wants because you're in their class, okay? Don't worry about what the crazy guy on YouTube says, all right? So you can pay attention to me on how to do the math, but then things like that, your teacher wants it written a certain way, you do what they want because you're in their class, okay? So, but that's what I prefer because that way I require my students to do that, and I say, look, this tells me you know it factors and you know nothing divides out, all right? So let's simplify some of these. So if we wanted to simplify this, we have a fraction there. We don't have any other fraction. We're not add, subtracting. We're just simplifying. So here, what can I do with those two terms? Do they have anything in common? Right? Any way we know how to factor is fair game here. So here, this is a GCF of what? 5. And we're left with x plus 2. And then in the denominator, can I factor 15x? No, I'm not going to worry about 15 factoring into some two, whatever. I just mean, can I take out a GCF or grouping or difference of squares or something like that? So 5 over 15, if I look at this, because 5 is times all of this, I know that's 2 terms over here, but 5 is times it. There's a parenthesis there. Then that's all one term. The whole reason that I do this is all one term now. We went from 2 terms to 1 term, okay? But my one term has a factor and a second factor. It has 2 factors, and the second factor has 2 terms. But it still has one overall term because it's factored, it's multiplied. So now this 5 and this 15, because this is also one term, right? What separates terms? Pluses or minuses. So because it's one term over one term, I can now cross my 5 and 15 out because they have a common factor of 5, 1 and 3. So this is going to become what? X plus 2. And if you leave it in parentheses, that's okay. It's overkill here, but you can. Over what? 3x. Now look, it is understood, by the way, when you write a slanted fraction, that this is in parentheses and this is in parentheses. Okay? And the whole thing, when it's a horizontal fraction, it's understood that these things are in parentheses. The numerator's in a parenthesis, the denominator's in a parenthesis, and the entire fraction is in a parenthesis. Okay? Let me say something about this because I just said horizontal fraction and I want to talk about slanted fractions. If you write slanted fractions, here's my advice. Don't. Slanted fractions are something that sometimes work and sometimes don't work. And I know I have teachers who will argue with me and say, well, this is on the same line. That means it's in parentheses. No, it doesn't. What you really just wrote here is this. All right, I've been doing this for 2 decades and I'm not backing down, okay? That's what you just wrote. If you wanted x plus 2 to be all in the numerator, you should have done that right there. Very few people teach or are taught to put parentheses for slanted fractions. Look, I have students all the time, Mr. Guest, math seemed to change from 9th grade to 10th grade, or even in the same grade, it changed one day to the next. That's because things like this are done where sometimes it's okay and sometimes it's not. I just don't teach anything like that. I do always works in my class at every level. I always do always works. When I do always works, then nothing changes in my class for my students. All right? So when you watch my videos, I'm only going to draw horizontal fraction lines, no slanted ones, because I don't like them because of this reason right here. So rather than when does it work and when does it not work, just don't ever write one again. Then you don't have to worry about it. And what happens is, see, math teachers, they understand. They know when it works and when it doesn't. They understand when they write it a certain way or whatever, but it confuses students. We shouldn't do that as math teachers, in my opinion, okay? So here we go. We're going to write horizontal fraction. This x is a part of two terms. I cannot cross those out. No, you cannot do that, all right? So then this is my final answer, x plus 2 over 3x. The next one, I have two terms up here again. What factors out of that? Anything? Is there a GCF? Yep. 7. What's left over? Y minus 11. All right, let's look down here. Does anything factor out of this one? Yep. What factors out of it? A 5, right? And what's left over? Y minus 11. Well, would you look at that? Now, this factor and this factor are identical. Okay, and again, the whole thing is factored. This is all one big term with two factors. One factor, two factor. The second factor there has two terms, but the whole thing is one term. This divides out with this, and I'm left with 7 over 5. If I had 7 plus y minus 11 over this, I could not cross this out because of that plus sign, okay? I cannot cross that out because of that plus sign. But there's no plus sign in between these here, so it's all one term. I can do that. All right, so 7/5 is my final answer here. So then here, try this one in gray here. This is 3 terms, no GCF with a 1 in the front. That's what I call list method. If you have trouble factoring these, go watch that list method video. It will help you. X and X. And then 16. Oops, I shouldn't write that down yet. Factors of 16 that add to give me 8. Okay? So I have 1 and 16, 2 and 8, or 4. I don't know why I wrote a line there. Or 4 and 4. Well, 4 plus 4 is 8. So then 4 and 4, and then this says they're the same. In my mind, I say that when I read it, I go both negative. They're both negative. So negative and negative. And then we'll change colors here to this pink or fuchsia for this one down here. 2 terms. Do I have a GCF? 3. What's left? X minus 4. Well, guess what? X minus 4 is gone. This X minus 4 doesn't have anything to divide. Don't cross it out with that one. You already used that one. You can't use it again. So we're left with X minus 4 over 3, and nothing divides out there, so I'm done. X minus 4 over 3. X minus 4 over 3. So y plus 5 over y squared minus 25. So here we have y plus 5. That will not factor. And then this one here, 2 terms. We have y and y. Because there's no GCF here. Oops, let me extend that out in orange. We have 2 terms here. There's no GCF. And the reason I'm doing this is because even power minus sign and a perfect square, that says difference of squares. So y's, and then you have 5's, and one's a plus and one's a minus. And remember that this is understood to be in parentheses. So that means that this and this divide out, and I'm left with just y minus 5. But again, it's in the bottom in the denominator. If I divide everything out, it's 1. Okay? So look, these don't cancel, right? So they divide out. If they cancel, they go to 0. I know I was taught cancel. Your teacher was taught cancel. No book in my office more than 30 years old or less than 30 years old says the word cancel anymore. All right? So it divides out. Oh, let me go back. I'm sorry. 1 over y minus 5. So here, I'm going to try to factor this one. 3 terms, 1 in the front. It's list methods, what I call it. So M and M. And we have let's see, I shouldn't write it down yet because it's 1 and 4 or it's 2 and 2. 1 and 4 add to give me 5. Right? So 1 and 4, and then they're both positive is how I read it. Okay? It's the same in my mind, but then both positive. So both positive. And that's the 1 and the 4. And then the one underneath it, again, 3 terms, no GCF, 1 in the front, so it's list method again. I want to say 1 and 5. There's no other factors that subtract to give me 4. Well, that's going to be it, 1 and 5, right? So this time I put the bigger number first. It doesn't matter. What matters is you put a plus 5 or a minus 5 correctly. Bigger number here gets a negative. In my mind, I say that this tells me different, but I say it out loud as bigger number gets that sign. Bigger number is a negative. So 5 is bigger than 1, it gets the negative, and they're different, so the 1 gets a positive. And then I go back and, okay, this one and this one are the same, right? Again, there's no pluses or minuses in here. That's why I can divide this out, okay? So that's gone, all right? And then this one doesn't have anything, so it has to stay. So I'm left with m plus 4 over m minus 5. And again, you can't cross those out because they're part of two terms, okay? Anything two or more terms, you can't cross one term out. Never can you do that, ever in the history of math, the present of math or the future of math. All right, so can I factor 3w plus 5? Nope, so just bring it down, 3w plus 5. Can I factor 3w plus 8? Nope. No GCF. Not see, it's two terms. So is there a GCF? No. Is it difference of squares? No. It's got to have a power. It's got to be an even power. Is it SOPs? Sum or difference of cubes? Nope. So neither one of those factor. So guess what? This is one of the rare cases where the problem is your answer. All right. But again, your teacher may require you to say that it's already in simplest form. All right. That's what our textbook does that I currently use. Okay. And some textbooks I've used in the past want you to write down what I just put in the blank. So let me use my Jedi mind tricks again and try to write this where you can sort of read it already in simple. This is why I'm a math teacher, so I don't have to write so many letters and words, because that's a challenge for me. All right, so let's look at this one. Oh boy, look at this. If I go to factor this one here, there's three terms there, and there's not a 1 in the front with no GCF. That means this is what I call bottoms up, okay? So some really smart person came up with this, and it works, and I like it, and so I use it. So I'm gonna come down here, and I'm going to put my stuff in parentheses at some point, but I can't go straight to the answer here. When I do bottoms up, I actually transform the problem. I multiply that 3 in the front by the negative 4 in the back. So I'm going to come over here in a thought cloud, and I'm going to transform my problem into a list method to make it easier for me to factor. So x squared plus 4x minus 3 times 4 is 12. So now I'm looking for factor of 12 to subtract to give me 4. That method doesn't work when there's something other than a 1 right here. So that's why I can do that now. 1 and 12, 2 and 6, or 3 and 4. 2 and 6, right? 6 minus 2 is 4. So come over here and say x. I meant to put equals. X, and I have 2 and 6, and the bigger number gets a positive. That's how I read that. So 6 is positive and 2 gets a negative because that says different. I say that in my mind, but I say bigger out loud. Since that's the case, I come back and go, wait a minute. I need to now, I multiply by 3. I've got to divide by 3 here and here. All right? So divide by 3 here and here. 2 over 3 does not simplify, so I bring the bottom up. That's the bottoms up part. 3x minus 2. And then here, 6 over 3 becomes a 2, and that's the 1. There's nothing to bring up, so that just simply becomes x plus 2. And so, guess what? 3 terms, no GCF, and a 6 in the front. That is also bottoms up. Take the 6 times the 2. And I'm going to come over here in another thought cloud. All right? And I'm going to do the same thing I just did. X squared minus x, and minus 2 times 6 is 12. So I have the same list of factors, but this time I'm not trying to subtract to get 4. I'm trying to subtract to get 1. Right? There's an understood 1 in front of that x. So 4 minus 3 is 1. So I'm going to say x and 4 and x and 3. Okay? And then, look, I know this is a negative there. I'm going to come back to my negative. This, in my mind, says different. I read it out loud as bigger number gets a negative. Which one of these is bigger? The 4. It gets the negative. And the 3 gets a positive. Then I say, wait a minute. I got to transform it back. I multiply by 6, so I have to do what? Divide by 6. So 4 and 6. Now, I know that 4 doesn't go into 6, but they have a 2 in common. So simplify it to 2 over 3, and that 3 comes up. So that's going to be 3x minus 2. And then the next one, 3 over 6. The 2 is in the bottom. The denominator this time, there's a 1 up top. You've got to have the 1. 2 comes in front of the x, so that becomes what? 2x plus 1. So does anything divide out here? Well, 3x minus 2 is the same thing here and here, right? So guess what? That most definitely divides out. X plus 2 has nothing like it in the denominator, so we are left with x plus 2 over 2x plus 1. And you can't cross the 2's or the x's out here because you have two terms. You cannot cross a single term out of a string of terms. All right? X plus 2 over 2x plus 1. X plus 2 over 2x plus 1. So here I'm going to try again to factor this. It's three terms, a 1 in the front, no GCF, so this is list method. I want factors of 81 that add to give me 18. So 1 and 81, you got 3 and 22, doesn't work. 3 and 27, 4, 5, 6, 7, 8, and 9. So 9 and 9 gives me 18, right? So this is going to be P and 9 and P and 9. And then this says they're both negative. Both negative. Now, by the way, I'm about to see if something divides out, but if that's all my answer was, I would write that as squared. But here, I have more to the problem, so don't do that just yet. I look down here, it's two terms. There's no GCF, but it's even power, minus sign, and a perfect square, so that is difference of squares. So P and 9 and P and 9, and one is positive, the other is negative. You can put the minus first, and I just usually put the plus first. I think my first algebra teacher that taught me this did that, and that's why I do it. I don't know why else. So P minus 9 is gone. Change colors here. P minus 9 is gone. This P minus 9 stays because I don't have another one to divide out with it. So it's P minus 9 over P plus 9. And look, that you can't do anything with that. Those P's and 9's don't divide out, and every sign did not change. If every sign changed, we might could do something with that, but it doesn't. So we're done. P minus 9 over P plus 9. So here, look at this. I have how many terms up here? 4. When I have four terms, I try the first two and I try the last two. And that may not work. I may have to rearrange my terms, but we do something called grouping, right? I try to group, and a group is just a GCF that I've labeled in brown, a GCF of these first two terms. What do the first two terms have in common? So let me go ahead and change this back to blue here. Let's see. The first two terms have what in common? They have a y squared, and I'm left with y plus 4, okay? And then I do another GCF of these two terms, and what do they have in common? Well, they have a 3 in common. The other thing is I need a sign right here. Well, I usually try this one. It may not work, but I'm going to try it, take a negative out, and what am I left with? Y and 4. But in this case, if I do that, and notice I'm going to extend this out to make sure it's long enough. If I do that, then I need a negative 3 times a negative 4 gives me a negative 12. Nope. I don't need a negative 4. I need a what? A positive 4. That way a negative times a positive gives me the negative I have here. Right? So did grouping work? And I claim yes, because these two things are the same. So what I'm going to do then is come down here. I know I'm writing my fraction down multiple times here, but I should be close to done. Y plus 4 is my GCF. You always bring your GCF out front, and we don't square it. We don't square that. We didn't square the y. We didn't square the 3 when we brought it out. So we squared the y because there was y squared in both terms here, not because we brought out something else. And then what's left over? Well, in the brown, I'm left with y squared. And in the green, I'm left with minus 3. Because this power is bigger than 1, I ask myself, will it go any further? Even power minus, but that's not a perfect square, so I don't go any further with it. It won't go any further. And then I ask myself, okay, how do I factor? Can I factor this one? Nope. Just bring down y plus 4. But remember, that's understood because it's the entire denominator to be like that. So now these things divide out, and I'm simply left with y squared. Do I need 1 over that, or do I need that over 1? No, everything's understood to be over 1, and that y squared minus 3 is already in the top of the numerator, so it just stays there. And it won't factor anymore. So y squared minus 3. Y squared minus 3. All right, look at this one. X minus 5 over 5 minus x. Wait a minute, that looks really kind of similar. Well, let's look at something. I can't really factor that, so I'm going to say x minus 5. I can, however, look at this and go, wait a minute. What if I factored a negative out? Just because my x is negative. That's typically what authors try to get us to do when the x is negative, the leading term is negative, leading coefficient. So negative, if I do that, what kind of x do I now have? Positive. I'm going to rearrange the order. I'm going to put this one here. And what kind of 5 if I take a negative out? It's what? Minus 5. Now that's nice because look what happens. X minus 5 divides out and they become 1s, and I get 1 over negative 1, which is just negative 1. Now that's a whole bunch of work to get to negative 1. I want you to learn to recognize if all the signs change. What kind of x was here? Positive. That was negative. Did it change? Yep. Negative 5 to positive 5. Did it change? Yep. If all the signs change, and that's the only difference in the numerator and denominator, the top and the bottom, the answer is always negative 1. If they're the same, it's 1. If all the signs change, then you change the sign. It's negative 1. So here, rather than try to factor negative out like we did here because the highest power is negative, what kind of v squared is this? Positive, negative. Did it change? Yep. Negative 3v to positive 3v. Did it change? Yep. Negative 11 to positive 11. Did it change? Yep. If every sign changes, y'all, if one of those signs didn't change, this wouldn't work. But they all changed, so the answer is simply negative 1. All right? They all changed, so it is simply negative 1. So now let's factor this one in the blue here. This is going to be list method because the 1's in the front, no GCF, 3 terms. So it's going to be x and x, and I want the factors of 12 that do what? Add to give me 7, I'm sorry. So the factors of 12, that's the important thing here. 1 and 12, 2 and 6, 3 and 4. 3 plus 4 is 7, and they're both negative. Negative and negative. I can't factor that. If you want to take the negative out, you can, but I can say 3 minus x, and then I go, look, positive to negative, did that change? Yep. Negative to positive, did that change? Yep. Did everything change in this one for this one? Yes, it did. That means I can cross these two things out and they become what? Let me erase my check marks here. All right. They become what? Negative 1. So this becomes negative x minus 4. I'm completely okay with this answer, but let me give you the other forms of the answer as well because your teacher may want this, or if you're using a software package, it may do that. If I have this, I distribute that negative, I end up with, this is the same thing. I'm just going to put or, it's equals, it's or it can be negative x, and then negative times negative is plus 4, or the other way you could write it is 4 minus x if you're not required to write it in descending order. So any one of those 3 answers would work great for me. I would take this one that I have boxed, I would take this one, or I would take this one. They would all be good for me. Okay? So, but you may not be in my class, so you do what your teacher wants you to do. All right, so hopefully this helps you with simplifying these rational expressions. Don't forget that all of these have restrictions. I just didn't spend the time finding them, but there's a video for that.